Here is a groundbreaking tool that lets you monitor GPIO pin activities live, right from any browser. It's like having X-ray vision. And if you're like me, facing challenges in your microcontroller projects, sometimes feeling overwhelmed, this tool is a game changer you don't want to miss. I developed it for my own use, but now I'm thrilled to share it with you as an easy-to-use library. In just a few moments, I demonstrate how effortlessly you can integrate this tool into your projects with only 4 lines of code. But first, let's jump into some practical examples to witness the impact of this library to level up your microcontroller troubleshooting process. Here, I have an ESP32 V-room. Now watch closely. Even though this board is essentially bare, running an empty sketch, we can see that some pins are active. This is the natural state of the board, untouched by any code. Understanding this baseline activity is crucial. Here is another ESP32 with several LEDs controlled by pulse width modulation, and 3 additional LEDs operated with digital pins alongside a rotary encoder. Using the GPIO Viewer, we can clearly see the signals being actively sent to the pins connected to the blue LEDs. And despite receiving signals, one of the LEDs isn't lighting up. We know the code is working as expected. We see it live on the GPIO Viewer. The wiring is the issue. The non-functioning LED is actually connected with reversed polarity. A simple but common mistake. If I flip it around, the LED springs to life, glowing as intended. The GPIO Viewer saves time and eliminates the guessworks, helping you to focus on the creative aspects of your project. I've connected the rotary encoder to control a set of green LEDs. Watch closely as I turn the encoder. On the GPIO Viewer, you can see the corresponding pins springing to life in perfect sync with each rotation I make. The GPIO Viewer is capturing every subtle change in real time, displaying the activation of each pin as I manipulate the encoder. Each turn of the encoder results in an immediate visual response on the screen. It's not just about saying that the system works. It's about understanding how it works. Alright, it's time to see how you can harness the power of the GPIO Viewer for your ESP32 projects. Trust me, it's easier than you think. First things first, head over to my GitHub repository to get the library. The link is in the video description. Simply download the latest release and install it using the Arduino IDE. You also need the ESPAsyncWebServer library. Install it in the same way you did the GPIO Viewer. The last library to install, AsyncTCP, can be installed using the Arduino IDE Library Manager. Now let's speak into the example that comes with the GPIO Viewer library. Here's the magic part. You need to include the GPIO Viewer's header file at the very top of your project. This is crucial, as it needs to be the first include. Then we declare a global variable for the GPIO Viewer, simple and straightforward. If your project doesn't connect to Wi-Fi, no worries. Use the built-in Connect to Wi-Fi function provided by the library. And if your project is already Wi-Fi enabled, you can just comment out this line. And here's the final touch. At the very end of your setup function, add this single line to kickstart the GPIO Viewer web application. That's it. Now let's upload this code to our ESP32 and watch the magic happen. Once the GPIO Viewer finishes its initialization, it will print a URL in the serial monitor. This is your golden ticket. Copy that URL, paste it into your browser, and voila, you're now watching the live action of your pins right on your screen. The GPIO Viewer extends beyond your computer. Any device with a browser can become your GPIO monitoring station. All you need to do is open the browser on your device and enter the URL displayed in the serial monitor. It's that straightforward. No additional setup, no complex configurations. Now let's integrate it into an existing project of mine, the Millennium Falcon props, a quiet large code base that simulates a console in the Millennium Falcon. We start by adding the GPIO Viewer header file as our first include in the code. Next, we declare the GPIO Viewer as a global variable, just one simple line of code, and we're halfway there. Now, since this Millennium Falcon project already connects to Wi-Fi, we can skip straight to the final step. We simply add this one line to the head of our setup function to activate the GPIO Viewer. That's it. Our integration is complete. Let's upload this updated code to our ESP32. Once it's up and running, I can use GPIO Viewer to observe the pin activities live. This isn't just coding, it's bringing a project to life. There are two things you can configure in the GPIO Viewer. First up, the sampling interval. This is the rate at which the GPIO Viewer checks and updates the status of your pins. By default, it's set to 100 milliseconds, providing a smooth and responsive view of your pin activities. But if you want to change it, just use the set sampling interval function. The second configurable element is the port for the GPIO Viewer's web application. The default port is set to 8080. You can easily change the port number in your code using the set port function. The GPIO Viewer supports different ESP32 boards. You can see the list in the GPIO Viewer web application or in the library's repository. And if your board isn't on the list, you can use the generic view to see all pin activities. You can also request a board addition. To do so, just head over to GPIO Viewer's GitHub repository and navigate to the Issues section. There you can create a new issue. And be sure to specify the exact model of your ESP32 board and include a URL to an image of the board. This will help me on adding support for your specific board. The GPIO Viewer is a game changer for anyone working with ESP32. Its real-time pin visualization simplifies troubleshooting and enhances project development. With super easy integration and evolving board support, it's an essential tool for both beginners and experts. Let me know your thoughts and your suggestions and improvements on the GPIO Viewer in the comments below. I'm excited to hear how this tool could transform your ESP32 projects. Thanks for watching.